is a detailed explanation for the homework from Friday. We are solving these quadratic equations. Typically, what we learned maybe 2 or 3 months ago is that we would factor these. We'd turn them, we'd use A times C, we'd come up with, two binomials, n, n minus 10, n plus 3 equals 0. We use the 0 property. We set each one equal to 0. And we find that n equals 10 and n equals -3. And we have -3, 10 are the two solutions. And that works. And you should absolutely use that technique if it is factorable, if this quadratic is factorable. But we also know that sometimes in situations we end up with unfactorable, that my A times C, and when I find the signs are different and the bigger is negative, that they don't equal my middle, and we couldn't move any further. So that's why we created the quadratic formula. And the quadratic formula says the variable, n in this case, is the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So one of my first steps is to figure out what my a, b, and c is. So my a is going to be 1. It's always the coefficient of my squared variable. B is going to equal -7. That's always the coefficient of my variable to the first degree. And my c is going to be my constant, which is -30. And I'm going to utilize those values when I plug in for the b's. So wherever I see a b value, I'm going to plug in -7. Wherever I see an a value, I'm going to plug in 1. And wherever I see a c value, I'm going to plug in -30. So I'm just filling in for those variables. So we get n equals the opposite of my b value plus or minus the square root of my b value squared minus 4 times a times c all over 2 times my a value. So we see, does it work color coding? My b is -7, my a is 1, and my c was -30. Yeah, okay, good. And then everything else is the formula. So now let's simplify. So n equals, the opposite of -7 is +7, plus or minus -7 squared. -7 times -7 is +49. -4 times 1 is -4 times -30 is +120. All over 2 times 1 is 2. Now we can start simplifying that radical. N equals 7 plus or minus the square root. 49 plus 120 is 169 over 2. Square root of 169, I know that equals 13, 13 over 2. And now we're going to split it. So we have 7 plus 13 over 2, and we have the negative side of 13 over 2. That gives me 20 over 2, which equals 10. And we have -6 over 2, which is -3. So my solutions for n are going to be -3 and 10. And that's how I write the solutions in numerical order. So those are the two values. And if you remember in the beginning of the video, I told you it was going to be -3 and 10, because this one is factorable. So if we were on a test in on an SAT, an HSPT, a placement test, we would not. Now, here's the other thing is, some teachers teach you this first and tell you to do it. And then they go, oh, there's also a quicker way. So this will work with every single problem. Every single quadratic equation can utilize the quadratic formula. Factoring only works for a handful of them, as we've seen. It doesn't always work. This will always work 100% of the time. All right, so standard form, is it set equal to 0? I forgot to sort of point that out. Yes, so we're going to take my A, which is 6, my B, which is 0, and my C, which is negative 54. Opposite of B, plus or minus square root of B squared minus 4 times A times C. That's going to be a really big number. Times 2 times A. So negative 0 doesn't do anything to it, so you're left with plus or minus. 0 squared doesn't do anything. Negative 4 times 6 is negative 24 times, what is it, 54? 54 is a humongous 1296. So negative times negative is positive 1296 over 12. Let's see if 1296 is a square root. 36, baby! 36. So it is a perfect square. So we get plus or minus 36 over 12. So we're going to make this plus 36 over 12, and that's not a good 12, and negative 36 over 12. That can simplify to 3. This can simplify to negative 3. So my solution, what's my variable? M. So M is going to equal, we can write this intelligently, plus or minus 3. You also could have written it as negative 3, positive 3. Same answer. Number 3, speaking of 3's, it's set equal to 0. That's good. So we're going to pull our A, B, and C. A is equal to 1, B is equal to 10, C is equal to 25. Opposite of B, plus or minus square root of B squared minus 4 times A times C, all over 2A. Negative 10 plus or minus 10 squared is 100 minus 4 times 1 times 25 is 100 all over 2. Ooh, this is cool. Negative 10 plus or minus the square root of 0 over 2. Square root of 0 is 0. So you have negative 10 plus or minus 0 over 2. So you have negative 10 plus 0 over 2, and you have negative 10 minus 0 over 2. That gives me negative 10 over 2, which is negative 5. This gives me negative 10 over 2, which is negative 5. So in this situation, I only have one solution, and that will happen. Remember, these double as intercepts. They double as x-intercepts because this is where my y typically is, and there's a 0 in there. So it's a nice way of solving. So the other thing is this plus or minus affects this 0, not the negative 10. It's only plus 0 or minus 0. So we get one solution. That happens every now and then. And that was x. X equals. All right, set equal to 0, that's good. A equals 3, B equals 3, and C equals negative 60. Opposite of B, plus or minus square root of B squared minus 4 times A times C. Yikes, that's going to be a big number. Big boy. One of my favorite commercials. 3 squared is 9. Negative 4 times 3 is 12. 12 times negative 60 is positive 720. Yeah, 720 over 6, 2 times 3. So we get negative 3 plus or minus the square root 729 over 6. I think we've already done that today. 729 square root 27. So we get negative 3 plus or minus 27 over 6. So we get negative 3 plus 27 over 6. And we get negative 3 minus 27 over 6. That's going to be 24 over 6, which equals 4. Nice and clean. And this gives us negative 30 over 6, which is negative 5. Yes. What's my variable? It's my starting variable, A. So A equals solution set negative 5, 4. Always put your solutions in numeric order. All right. Let's do number 5. Oh, here's my first one. I notice that it's not equal to 0. I have to set it equal to 0. So the question is, do I move this over here? Do I move the 4a over, or do I move the 39 and the a to the left side? Well, the contingency is your highest variable, the highest power of your variable. This is to the second, this is to the first, and this doesn't even have a power. Your highest exponent has to be positive. So the coefficient is a positive 4. So that's going to stay on the left side, and I'm going to move both of these things over. So what's going to get rid of a positive a? A negative a. What I do to one side, I do to the other. These are not like terms, so I cannot combine them. And now I got to move that positive 39 by subtracting 39. We get 4a squared minus a minus 39 equals 0. Now we have to find what is my a, b, and c. A is going to be the coefficient of a squared, which is 4. B is going to be negative 1. And c is going to be negative 39. Probably going to run out of space over here, so let's... Oh, I moved that. Didn't mean to do that. That's a whole entire page. You're going to make it hard. Oh, nice. Look at that. Oh, gosh. I love it. All right. That's good. Now, let's do the quadratic formula. The opposite of my b value plus or minus the square root of my b value squared minus 4 times a times c all over, that doesn't look like a c, 39 all over 2 times a, which is 4. So the opposite of negative 1 is 1 plus or minus square root. Negative 1 quantity squared is 1. Negative 4 times 4 is negative 16. 16 times, what is that, 39. 16 times 39 gives me 624. So plus 624. 624, 2 times 4 is 8. We have 1 plus or minus 625 over 8. Let's see if 625, 625. Are you a perfect square? Yes, you are. So we have 1 plus or minus 25 over 8. 1 plus 25 over 8. 1 minus 25 over 8. That gives me 26 over 8, which can be reduced to 13/4. And this gives me negative 24/8, which is negative 3. So what variable am I using? A. So we would write A equals negative 3, comma, positive 13/4. Those are the two solutions to that equation. Let's set it equal to 0. Add 2. 2n squared plus 4n plus 2 equals 0. My A is 2. My B is 4. My C is 2. Opposite of B, plus or minus square root of B squared minus 4 times A times C all over 2 times A. Negative 4 plus or minus 16 minus 16 all over 4. Whoa. Negative 4 plus or minus the square root of 0 over 4. This is a fun one. Negative 4 plus or minus 0 over 4. Negative 4 plus 0 over 4. Negative 4 minus 0 over 4. Negative 4 over 4, which is negative 1. Negative 4 over 4, which is negative 1. So n is my variable. So n equals, there's only one solution. You will not write negative 1 twice. It's the same number. There's only one solution. Number 7. All right, there's my p squared. It's my biggest exponent, variable with the exponent. So we're going to move everything else over. So we're going to get rid of that negative 3p by adding 3p. 6p squared does not combine with 3p because they are unlike terms. And I'm going to write it in standard form, p squared, p, and then no variable, the constant. And now I can pull out my a, my b, and my c. Opposite of b, plus or minus square root of b squared, minus 4 times a times c, all over 2 times a. Ooh, this looks like it's going to be a good one. Negative 3 plus or minus 9 plus, what's 24? 24 times 9. I have no idea what 24 times 9 is. 24 times 9, 216. 216 over 12. Negative 3 plus or minus 9 plus 216 is 225 over 12. Negative 3 plus or minus 225. I think that's 15. 225 square root 15 over 12. Let's split it. Negative 3 plus 15 over 12 and negative 3 minus 15 over 12. That's going to give me 12 over 12, which equals 1. Negative 3 minus 15 is negative 18 over 12, which is negative 9/6, which is negative 3/2. Got to reduce. Don't leave it as negative 9/6. Reduce it completely. That's my variable. P equals negative value first, negative 3/2, comma 1. Oh, I got a couple more. What? How many problems did I do? 10. Wowzers. Okay. We got some work still to do. All right, this is a good one again. It's in standard form. It is set equal to 0. My A is 5. My B is 0. My C is negative 20. Opposite of B, plus or minus B squared minus 4 times A times C, all over 2 times A. That negative 0 goes away. You're just left with plus or minus 0 minus 5 times negative 20 is negative 100. So positive 400 all over 10. So we get plus or minus square root of 400 over 10. We can use our calculator here just to see if it was a perfect square, which it is 20. So you get plus or minus 20 over 10. So that is plus 20 over 10 and negative 20 over 10. That equals 2. This equals negative 2. So my solution with the variable n equals plus or minus 2. I would also accept negative 2 comma 2. Number 9. Oh, look at that. Minus 4, we have to set it equal to 0. Now I can pull my A, my B, and my C. Opposite of B, plus or minus square root B squared minus 4 times A times C. Oh no. All over 2 times A. The negative 0 goes away. You're left with plus or minus 0 minus plus 160 over 20. 2 times 10 is 20. Negative 4 times 10 is negative 40. Negative 40 times negative 4 is positive 160. So you get plus or minus 160 over 20. Now, 160, if I do this, here we go, 160. Let's do square root. What does that tell you? Yes, it's not a perfect square. We're not going to write negative. We're not going to write 12.6491 blah blah blah. Nope. We're going to keep it as a rational number, but we're going to simplify rad 160. So 160 can be broken into rad 16, rad 10. And why did I pick 16? Because it's a perfect square. Let's move you over a little bit. Oh, I did it again. Let's see where that goes. Yikes. I think that's nice. Let's move this. Let's move it. Oh my goodness. Stop it. We're getting tired. We're on the last couple. Mr. Max had a long day. So we're going to do plus or minus. Square root of 16 is 4. Rad 10 has no perfect square factors in it. Over 20. Now, we can simplify this. This was a major problem on the radical assessment. Lots of people did not simplify outsides with outsides. We can simplify those. Now, we can simplify them sooner or later. Let's do it sooner. So this becomes plus or minus 2 rad 10 over 10. That can be simplified. So we make that plus or minus 1, or rad 10 over 5. The 10 inside the radical does not get simplified. That is inside, which is different from the outside stuff. We're simplifying outside stuff. So this is a good trick question. All right, so we can write this as my solution, or we can see that this can be written as negative rad 10 over 5, comma, rad 10 over 5. The 10 and the 5 cannot, because one is inside, one is outside the radical. Both are acceptable. Our variable is r, so we could write r equals. That's not a square root sign. All right, last one. R squared is there. Let's add the 9r. Add the 9r. 3r squared plus 9r equals negative 3. Let's add the 3 to set it equal to 0. 3r squared plus 9r plus 3. I think we've done this one. Have we done this one? Where I have 3, 9, and 3? Oh, no. No, I didn't. Nope. Okay. Bad memory. Whoop. Let's see. Make sure all of our answers good. Yes. All right. So this is going to be a fun one. You just saw the answer. It's got a lot of radicals in it. So my A is 3, my B is 9, and my C is 3. Opposite of B, plus or minus square root of B squared minus 4 times A times C, all over 2 times A. Negative 9 plus or minus square root of 81 minus, what's that, 9 times 4 is 36, all over 6. Negative 9 plus or minus 81 minus 36 gives you 45 over 6. 7, yeah, 45. Now, can I simplify rad 45? Yes. To rad 9, rad 5. Hello, silly. Over 6. So I'm going to simplify that. Negative 9 plus or minus 3 rad 5 over 6. So I'm looking at those outsides. Negative 9, positive plus or minus 3, and 6. Is there a common factor? Yes. 3 goes into all of them. 3 goes into all 3 of those. So if I divide each of those by 3, I get negative 3 plus or minus, that would be 1 rad 5 over 2. Because 3 goes into 6 2 times. So that's going to be my answer. What's my starting variable? R. So R equals, we can do that. You also could have done R equals negative 3 plus rad 5 over 2, negative 3 minus, whoa, rad 5 over 2. Both of those answers are correct. All right. Good luck. It's Friday. I hope you did well. Come and see me Monday if we have questions. Enjoy. Thank you for your patience. I'll see you when I get back.